Okay, so electrolysis, as we have already discussed, it's a chemical process that required electricity to break a compound, okay, or decompose a compound. So decomposition of a compound, that is an electrolyte, using electricity is called electrolysis. Okay, and for electrolysis we use electrolytic cell, and we have already discussed that what is an electrolytic cell. Basically, it a set of apparatus that include certain things, okay, to carry out electrolysis. We have already discussed. So first we will discuss electrolysis of molten compounds. And in our syllabus, we have to discuss electrolysis of molten binary compound. Binary mean a compound consisting of two elements. One must be a metal, other must be a non-metal. You know, ionic compounds are made up of metals and non-metals. Okay, so we are going to discuss electrolysis of molten binary compounds. Okay, beta. Sodium chloride is a binary compound. Lead to bromide is a binary compound. Aluminum oxide is a binary compound. Any compound consisting of two elements is called a binary compound. Okay, beta. Bi mean
Okay,
two.
sir.
A compound consisting of two elements is known as binary compound. So first of all, we are going to discuss, you can say this is the first case of electrolysis. That is the electrolysis of molten ionic compounds, which are always binary, mean they are consisting of two elements. Okay. So first example is electrolysis of molten lead to bromide. Its formula is PbR2. Solid lead to bromide does not conduct electricity because it has no free moving ions. All ions are closely packed together within the uh, lattice structure of giant ionic lattice or crystal lattice structure of lead to bromide. But when it is in molten state, ions are free to move. So in its liquid state, it does conduct electricity. Okay. Now ions carry positive charge and negative charge. For example,
Sir,
G beta.
like, are you sharing the screen? Like,
Yes, I am sharing the screen. Okay.
we cannot see.
Okay. Okay. Sorry,
No, sir,
I
I
forgot
can
to
see.
share. Yes.
I can see.
Okay. 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 So basically, I'm telling you that we are going to discuss electrolysis of molten lead to bromide. Its formula is PbBr2. It is an ionic compound. Okay. And it is a binary compound as well because it contains only lead and bromine elements. Okay. So molten lead to bromide conducts electricity because it has free moving ions, lead to positive and Br negative ions. Okay. When electricity is passed through molten lead to bromide, what happened? These are the two electrodes you can see. One is the cathode, a negative electrode, other is anode, the positive electrode. So as you know that opposite charges attract each other. So positively charged ions, lead to ions will move towards the cathode, and towards the anode, negative ions will move. Okay. Lead to ions lose electrons at cathode to deposit to form lead metal. Okay. So lead metal is a heavy metal. It will go down and will settle down as tiny droplets of lead. It will appear as shiny metal. Okay. Whereas bromide ions, being negatively charged, they will move towards the anode, and they already have electrons, extra electrons. They are negative ions, so they will lose electrons at anode and change into bromine atoms. And you know, bromine atoms cannot exist as an atomic form, so they combine to make bromine molecules. So bromine molecules are released as bromine vapors or bromine gas, which is brown in color, okay. So in this way, actually, we have broken down this compound into its elements. Now I'm going to explain this uh, using whiteboard. You have to wait for a few minutes. Okay, beta? Okay.
Okay.
Ji beta, now I'm going to share the whiteboard with you where I will make the diagram. Okay, beta? So first of all, you should know this is the formula of lead to bromide. Okay. Okay, Mariam.
Professor.
When lead to bromide is in liquid state, it will have lead to ions in its molten state and bromide ion in its molten state. Okay. In order to balance this equation, we will put 2 over here. So 1 lead ion and 2 bromide ions are shown in the equations to balance this equation. So lots of lead ions and lots of bromide ions will be there during the electrolysis. Okay. And what happened with lead to ions? These two will be attracted towards the cathode during electrolysis. Okay. Where lead to ions gain electrons because that is a negatively charged electrode. It forms lead metal. Okay, lead metal will be deposited at the bottom of the electrode as shiny droplet. Okay, is it clear? Whereas these bromide ions will move towards anode. Now anode is positively charged electrode. So negative ions will move towards the positive electrode where they lose electrons because they are already having electrons. They are already having electrons, extra electrons. They will lose electrons like this. Bromine ion change into bromine atom with the loss of electron. But as we know, bromine atom cannot exist as an atom, so they combine to form bromine gas, which will be released as brown fumes. Okay, so we can balance this equation, or we can write this equation like this as well. 2Br negative changes into bromine gas plus loss of electrons. Okay, as we are carrying out this reaction or this process at high temperature, that must be more than the melting point of lead to bromide. So that is definitely that will be a very high temperature. Okay, so at this temperature, bromine fumes or bromine gas will be formed at anode. So you will observe that brown fumes are coming out from the anode side. Okay, but at the bottom of the cathode, you will see that shiny droplet of lead metal will be deposited. Okay, so in this way, we have broken down this lead to bromide compound, which is very stable ionic compound, okay, into its element through electrolysis. So electrolysis is used to break this compound into its element like lead and bromine. Lead and bromine, okay. So first lead to bromide is in molten state, then it is electrolyzed using electricity. Lead metal will be formed at the cathode and bromine gas released at the anode. And this way we have broken down this compound into its elements. This decomposition is called electrolysis because it used electricity. Is it clear, Abdullah?
Okay.
Abdullah, any question, any problem?
No.
Okay. So I'm going to rewrite this equation once again, beta. Actually, we were having lead to bromide and its liquid state. And the liquid state it has free moving ions, lead to ions and bromide ions, Br negative ions. These ions will go towards which electrode, Mariam? The lead to ions will go towards
The
cathode or anode? Yes, cathode. Yes, cathode. They will move towards cathode. You know, Positive ions are called cations. Cations move towards cathode. Okay. Cations move towards cathode. Okay. Clear? These are cations. Cations. And these are anions. So at cathode, lead-2 ions gain electrons to make lead. Okay. Lead-2 ions gain electrons to make lead. Whereas at anode, bromide ions lose electrons to form bromine vapors or bromine gas is given off. Okay. So one thing you should keep in mind, for adding or addition or gain of electron, we always show electron in the reactant side with positive. Plus electrons mean electrons are going to add into this. Here we show electron on the other side, in the product side, it means electrons are being lost. So if we see that we have two negative charge over here, two negative charge in the right hand side. So equation is balanced with respect to charge. Here we have 2 plus and 2 minus, that is neutral. 2 plus, 2 minus cancel each other and we get neutral atom in this side. So this is how to write the half equation of the cathode reaction, and this is called anode reaction. The chemical change or the reaction that is happening at cathode is called cathode reaction, and the reaction that is happening at anode, that is called anode reaction. Okay, and this is the equation for the anode and this is equation for the cathode. So Abdullah, now you will tell me, is this loss of electron or gain of electron?
That okay. So that is gain of electron.
Gaining of electron. Yes, gain of electron is called reduction. That is called reduction. So now you have to relate this topic with the previous topic, redox reaction. And this is the loss of electron. We call it oxidation. We call it oxidation. Okay, beta?
Okay.
Mariam, now you should know that during electrolysis, reduction takes place at cathode always. So we can write it to memorize this red cat. What is meant by red cat? Red for reduction, cat for cathode. Reduction takes place at cathode. Okay, beta?
Okay.
Reduction is always take place at cathode. Red cat. We can memorize through this these two simple words. Red cat. Okay. And at anode, oxidation takes place during electrolysis. So we can write anox. Oxidation at anode. Okay. Anox. And for anode, ox for oxidation. Okay, beta?
Okay.
We can write it as cat red if we follow the same sequence like cathode for it, cathode, reduction, anode, oxidation. Okay. So this, how can we memorize these things in simple ways? Okay, beta? Cat red for cathode means at cathode reduction takes place due to gain of electrons. In an anode, electrons are always lost. Oxidation takes place, so that is called anox. N for anode, ox for oxidation. Okay, Abdullah?
Okay.
Did you get this or not?
Yes.
Okay. Now I will give you another example of electrolysis of a molten binary compound that must be ionic definitely. For example, we have sodium chloride. Sodium chloride, that that is an ionic compound. It has very high melting point, 801 degrees Celsius. So we have to keep the temperature during electrolysis more than the melting point of sodium chloride. So when it will be in molten state, it will have Na plus ion plus Cl negative ion. Okay. And molten state, what two ions, which two ions will be present in the liquid sodium chloride, beta?
Sodium and chloride.
Yes, sodium ions will move towards which electrodes?
Yeah, cathode.
Cathode. Beta, positive ions are called cations, and cations always move towards cathode during electrolysis. So they will come over here, move towards cathode. Now what happened with them? They will gain electrons to deposit sodium metal, which is silvery whitish in color, okay, on the surface of cathode. Okay, so this is gain of electron, and I told you that you can remember this cat red, cathode reduction, cat red. Okay, Abdullah.
Okay.
Cat red, cathode reduction. Okay, whereas chloride ions will move towards anode, Cl negative, where they lose electrons to make chlorine gas with the loss of electron. Now, in order to balance this equation, we will write 2 over here before chloride ion. 2 chloride ion will change it to 2 chlorine, a chlorine molecule consisting of 2 atoms and with the loss of 2 electrons. So this is oxidation. We call it oil, and it is anox. That is anox. What is anox, Mariam?
The
And for anode, ox for oxidation.
sorry,
Beta, it means oxidation takes place at anode. Oxidation always takes place at anode during electrolysis. Okay.
okay.
Oxidation is loss of electron, whereas reduction takes place at cathode always, and reduction is gain of electrons. Simple as that. Clear, beta?
Clear.
So we have discussed 2 examples of electrolysis of molten ionic compound. Now here you can see half equivalence. Lead ions. What happens with lead ions during electron lead to bromide? Lead to ions gain electrons to make lead that will be deposited as shiny droplet or liquid lead, gray colored molten globules at the bottom of beaker, gray or shiny colored, because metal, you know, they are always have shiny surface. Okay, so gray shiny colored molten globules at the bottom of the beaker will be seen here during electrolysis. Okay, beta.
Okay.
What happened at anode? Bromide ions lose electrons to make bromine, so brown gas is given off at the anode. So we can say that reddish brown or brown vapors seen at the anode. Okay. Okay, Mariam. So this is how we have broken down this lead to bromide into its element, lead and bromine, through electrolysis of this compound in its molten state or in its liquid state. Okay. Clear, Mariam?
Yes.
Now
Clear.
here we have, in this table, we can see several electrolysis, several compounds. Okay. That include electrolytes, reaction at anode and reaction at cathode. For example, I have just explained you that sodium chloride have Na plus and Cl negative ions in its molten state. At anode, chloride ions get discharged. This is called discharging of ion as well, because ions change into neutral atom or molecule this is negatively charged ion, it loses electrons to become neutral. So loss of electron is oxidation. We will observe that greenish yellow gas will be given off at anode. Whereas at cathode, sodium ions gain electrons to form sodium, that is reduction. And we observe that molten silvery globules are collected at the cathode. Okay, so products at anode is the chlorine gas and the cathode it's sodium metal. It is sodium metal. Okay, beta.
Okay.
These are called half equation because one of the equation is the equation at anode, the other equation is at the cathode. Okay.
Okay.
Next is if we do the electrolysis of potassium iodide in its molten state, it will have K positive and I negative ion. Why this happened? Because I told you that when ionic compounds are heated more than their melting point, they change into liquid state. After melting, they become molten, and molten state they have free moving ions. Okay, beta.
Okay.
During electrolysis, these positive opposite charged ions will move towards their respective electrodes. Positive ions will move towards the cathode, mean cations will move towards the cathode, anions or negative ions move towards the anode. So in this case, iodide ions will lose electrons to make iodine that will appear as purple vapors in the gaseous state, and potassium ions gain electrons to deposit potassium, and potassium is also molten silvery globules are collected at the cathode. Okay, so you can say that iodine is the product at the anode and potassium is the product at cathode. Okay, Mariam and Abdullah.
Okay.
Any question, beta?
No, sir.
Okay. Now let's say another example, sodium bromide. It's also a binary compound consisting of only sodium and bromine. When it is melted, it will have Na plus and Br negative ion in its molten state. During electrolysis, bromide ion will move towards the anode where they lose electrons to make bromine. Again, you will observe reddish brown or brown fumes given off at anode and due to formation of bromine gas, whereas at cathode, sodium ions gain electrons to make silvery whitish globules of sodium metal depositing or formed at the cathode. So sodium metal is the product. Okay, beta?
Okay.
Okay, so lead 2 iodide is another ionic compound. It contains lead ions and iodide ions. Again, iodide ions will discharge at anode by loss of electrons to make iodine. That will appear as purple vapors. And lead 2 ions at cathode gains electrons to make lead. Lead is a heavy metal that goes down, trickle down at the surface of, at the bottom of the cathode, where it will appear as shiny gray globules. Okay, beta? Okay.
Good.
So summary, electrolysis of molten ionic compounds. When a molten ionic compound is electrolyzed at the cathode, reduction takes place. And I told you that you should remember this word with cat red. Cathode reduction. Okay, beta? Cat red.
Okay.
Cat red, cathode. A reduction takes place at cathode. A metal is formed at the as a product. At anode, oxidation takes place. You can remember this by anox. And for anode, ox for oxidation. A non-metal is formed at the product as a product. Okay.
Okay, sir.
G. Abdullah, did you get this or not?
Yes.
Okay, let me explain this once more with a diagram. But for example, we have lead iodide an ionic compound. Okay. In its molten state, it will have free moving ions, lead-2 ions and I negative ions. So we will write 2I negative. So in this molten form of lead iodide, we will have lead ions and iodide ions. Okay. If we do the electrolysis of molten lead to iodide, we can make its diagram like this. This is, for example, a beaker in which we have one electrode that is made up of graphite. Other is also made up of graphite. If we connect these two electrodes with a battery like this, this is cathode and this is anode. Okay, beta? And this is electrolyte, that is PbI2 in its liquid state. Okay, beta? So this is how
Okay.
to draw the diagram of simple electrolytic cell to carry out the electrolysis of lead to bromide. Now, at anode, these ions will move. So iodide ions will come here and lead-2 ions will go here. Okay, so 2I negative ions, they will change to iodine vapors with the loss of electrons. So you will see, you will observe purple vapors, of iodine gas here on this electrode. Okay, whereas at cathode, Pb2 positive ions will gain electrons to deposit lead metal here. You will observe here the globules of shiny gray globules of lead metal depositing here, and lead-2 ions are discharged by gaining electrons to deposit lead. So this is the gain of electron, and gain of electron is called reduction. That is called reduction. This is oxidation. This is oxidation. Okay. So at anode, oxidation is taking place, whereas at cathode, reduction is taking place. And I told you that you can remember these two by cat red, cathode reduction, and anox, anode oxidation. Okay, Abdullah.
Okay.
So you should be able to explain this, that what is happening at anode, what is happening at cathode. I told you that iodide ions lose electrons to make iodine. This is called discharging of ions. So ions get discharged, mean they lose charge either by loss of electrons or by gain of electrons. So negatively charged mean they already have more electrons. They have excess of electron. They will get discharged by the loss of electrons to form iodine, whereas lead-2 ions get discharged by the gain of electrons to make lead on the surface of cathode. So this is how we can break this compound into its elements through electrolysis. So this is called electrolysis. Electrolysis is the decomposition of a compound or electrolyte using electricity. Okay, Mariam?
Okay, sir.
Abdullah, did you get this?
Yes.
Okay, good. So we have discussed the first case of electrolysis, that is the electrolysis of molten ionic compounds. Okay, molten ionic compounds, and we used inert electrodes, mostly graphite, because graphite is easily available and not very expensive. Whereas I told you that another electrode that can be used as inert electrode is platinum, and platinum is expensive metal. So all of these electrolysis are carried out using inert electrodes. कौन से electrode use किया हमने बेटा? Inert electrodes. जी अब्दुल्ला, हमने कौन से electrode use किए?
Inert electrode.
Inert electrodes. Okay. Inert electrodes means which do not react during electrolysis, or they do not react with electrolytes during the electrolysis, like graphite, which is a form of carbon that is a good conductor of electricity, and the other is platinum, which is expensive metal but very less reactive. So platinum and graphite are used as two inert electrodes, but mostly we use graphite electrodes, which are cheap and easily available. Okay.
Okay.
Okay, beta. So now I will show a video from YouTube. Okay, I'm going to stop here explanation. I'll show you the video that will help you to understand this more clearly. Okay, beta.
Okay, sir.
So we have almost 3 minutes remaining time in this meeting. So I'm going to finish here this meeting, and then you will join me once again after 2-3 minutes, and then I'll show you a video. Okay, beta.
Okay, sir.
So that's all for this class. Then we have next class and the next meeting where I will show you a video related to electrolysis. Thank you.